the input and output organization. So first we are going to see about what is input and output organization. What is the role of the input-output organization? You know very well, in our processor, there is a possibility we can able to connect more than one input and output devices. The way in which how these input and output devices are going to be communicate or connected with the processor will be taken up by the input and output organizations. Okay. So first we are going to see about data transfer technique. So normally the I/O subsystem of the computers provide an efficient mode of communication between a central system and the outside the environment. Okay. So obviously the I/O subsystems are going to be used. Okay, we are going to act as a bridge between that is where processor as well as outside the environment. Okay, it handle all the input and output operations of the computer system. So, for example, the input devices need to be communicate with the processor through this I/O organizations. Are going to be give the request. This request forward to the processor. Once the processor given the acknowledgements, then the I/O organizations will respond to the concerned input device. Then now the input devices are ready to transfer the data. Whatever the data transferred by the input device, that data is forwarded to the processor by these input-output organizations. Likewise, that output device are also. So there are different data transfer techniques available. Okay, the first one is peripheral devices. What is peripheral devices? Normally, the input-output devices that are connected to a computer are called as peripheral devices. So these devices are designed to read the information into or out, okay, of the memory unit upon the commands from the CPU and are considered to be the part of the computer system. So these devices are called peripherals. So what is peripherals? The peripherals are device, either input or output devices. So the devices are mainly used for whether it's going to be tried to given the input to the processor or input to the memory unit, or it's going to be tried to show the output whichever available in this memory unit. Okay, these devices we can call it as peripheral device. For example, keyboards, display units, I mean monitor, printers, all are example for peripheral devices. So normally there are different, there are three types of peripheral devices are available. One is input peripherals, another one is output peripheral, then third one is input-output peripherals. So what is input peripherals? The input peripherals allows the user input from the outside world to the computer. For example, keyboard and mouse and all. Okay, so this is mainly used for whatever that outside world information is available, by which we can able to give the input to the processor. That is the input peripheral devices. The next one is output peripherals. What is output peripherals? Allows the information output from the computer to the outside world. So this unit mainly used for whatever the computer's resultants available, that resultants is going to be shown to the outside world. Okay, that is output peripheral. Example, printers, monitor, and etc. Okay, these are examples for output peripherals. What is input and output peripherals? I mean, this is a combination of input peripherals and output peripherals. It allows both the input. Okay, that is from the outside world is going to be tried to receive the input, as well as is going to be allows the output. I mean, from the computer to the outside world is also going to be given. Okay, so it's going to be tried to perform both input and output operations. So we can call it as a input-output peripherals. For example, touch screens. Okay, in our mobile phone we are using nowadays touch screens, by which we can able to see the input. We can able to give the input as well as we can able to see the output. Understood? Whatever you are going to pressing your touch screen, that is your input. Then after pressing your computer, I mean your mobile phones are going to be given some output, that is your output. So obviously that touch screens are mainly used for input and output peripherals. This is an example, well-known example for input and output peripherals. Next one is, so whenever we go for I/O organizations, obviously in between the input devices as well as the processor or processor to output devices, we are going to be use one special hardware unit. That hardware units we can able to call it as interface. Now we are going to see that interface. The interface is a shared boundary between the two separate components of the computer system, which can be used to attach two or more components to the system for communication purpose. So it's an interface, like it's going to be connecting point by which, okay, the more than one components can able to connect together, by which they can able to communicate with each other. Through this communication, they can able to share the information. So that is the use of the interface. There are two types of interface available. One is CPU interface, another one is IO interface, that is input output interface. So here, what is CPU interface? The CPU interface, which is located under the CPU. So here, what happened? What are the there's a possibility in if you go for multi-processing system, there is more than one CPUs are going to be connected together. So that cases, okay, these interfaces are going to be used. Okay, that is the use of the CPU interface. But our topic is IO, so we are going to be discuss about IO interface in detail. The IO interfaces, okay, are mainly used to connect the peripheral to the computer, needs special communication link for interfacing with the CPU. Okay, it is a special hardware components between the CPU and peripherals, okay, to control or manage the input-output transfer. So these components are called input-output, okay, interface. So because they provide the communication link between the processor bus and the peripheral devices. Okay, they provide the method for transferring the information between the internal memory as well as the output devices. So that is the role of the input and the output interfaces. Next, we just move on to that mode of the IO data transfer. What are the different way we can transfer the data? Okay, that is, there are three common mode of data transfer between that processor as well as IO devices. Okay, the data transfer between the central unit, I mean CPU and IO devices, can be handled generally three types of the mode. Okay, the first one is program IO, second one is interrupt inserted IO, the third one is direct memory access. These are the three IO, okay, mode of data transfer. The first we are going to look at on that program IO. What is program IO? The program IO is that the instruction, okay, so we already framed some instruction in our program itself. Okay, make use of these instructions, your data transfers are going to be take place. I mean, your input devices or output devices are going to be trying to communicate with each other. But consider, now we are already studied C programming. In C programming, we have scanf and printf functions. Okay, so these are the well-known functions for input or output. Apart from that, lot of functions are available in C programming. For example, get ch, put ch, get char, put char. Then we have okay, get test and boot test. All those functions are available. These are example for the programming, that is IO instruction for the particular programming language. So make use of this particular programming language IO instruction. The data transfers are going to be take place. This is called as, okay, program IO. Okay, let's consider whenever we are going to using scanf function, scanf %d, comma, ampersand of p. Suppose we are giving that instruction in our part of our program. What happened? So this instruction instructs to the processor. You have to wait for getting the input from the that is standard input device. For example, keyboard. That is the meaning. Okay, so that's the things. Make use of this set of IO instruction. Okay, the programs, okay, the data transfers are going to be take place between your IO devices to and processor. I mean, input device to processor and processor to IO device. So let's consider make use of printf functions. What happens? So from processor to IO device, that is output devices is going to be showing the output. Okay, usually the program control data transfer to or from the CPU and peripheral. The transfer in the data under the program IO require constant monitoring of the peripheral by the CPU. Whenever we go for program IO, so need to be constantly monitoring whether the users are going to be given the input, whether that corresponding output devices are ready. Okay, then only, even though we are going to giving that instruction as a part of your program IO instruction, we need to be keep on monitoring whenever we go for program IO. The next one is interrupt inserted IO. Okay, so in the program IO method, the CPU stay in the program loop until the IO unit okay, indicate that ready for the data transfer. That's a problem we are facing the program IO. For example, Now we are running the program, addition of two number program, we just return in C programming. So, okay, we declare the two variable and we are going to try to get the two value for the variable. Let's consider the variables A and B. We just given scan of %D, %G, then ampersand of A, comma, ampersand of B. Like that we are given the instruction. Here what happened? By running the program, until the users are going to given the input, okay, the processor need to be wait. Understood? So that's the problem the CPU need to keep on monitoring until they get that input from the input device, need to be wait. Okay, so that's the problem we are facing your program IO. So this is a time consuming process because okay, sometimes that IO devices not response properly, okay, as per the expected speed of that CPU. So to overcome this problem, make use of the interrupt initiated IO, we are going to try to solve it. Okay, in this, when the interface determines that the peripheral is ready for data transfer, it generates an interrupt. So in this case, what happened? Whenever the IO device is ready to transfer the data, IO devices are going to be generate the interrupts. Okay, so I am ready to transfer the data. So after that, only the processor are going to be try to, okay, take care of these IO devices. Whereas program IO not like that. Once the instruction is get executed, need to be wait until the inputs are going to be given by this IO device. That's the meaning. So it generates an interrupt. After receiving the interrupt signal, the CPU stop the task which it is processing and service the IO transfer and then return back to the previous processing task. Understood? That is a interrupt initiated in the sense whenever we are going to be requesting through this interrupt, we are going to requesting. Now the processor are going to be stop the process. Then it's going to be tried to service the IO devices. Okay, requirements. Once the requirements is got over, then once again it's get back to whatever the previous works okay executed at the processor will continue. Okay, that is the interrupt initiated IO. That is the second technique. The third technique is, or is the first technique, obviously that entire IO data transfer, the processor need to be concentrated. That interrupt initiated, okay, they are doing that work whenever the interrupts arise. So until once it's given that enable signal, until that IO data transfer need to be concentrated. That is the interrupt IO. So here also the processor are need to be spending more time because until that bulk of data transfer between the processor as well as IO devices or IO device to memory. So this is another problem we are facing for interrupt initiated IO. I mean the processor need to be wait, need to be concentrate only that IO data transfer. They could not able to try to perform any other task. Okay, so obviously we are wasting the time, okay, for the processor. To overcome this, we just go for another technique, that is direct memory